Released April 10th, 2019, this is the first ever photograph taken of a black hole. Located at the heart of the M87 galaxy, the image shows a ring of dust and gas encompassing the mammoth black hole, which has a mass of 6.5 billion Earth suns. But capturing this astronomically important image wasn't just a case of pointing a telescope at a black hole and snapping a few pictures. The process was a whole lot more difficult than that. Because no light can escape them, black holes are invisible. The holes having an event horizon, a point of a black hole from which no light can escape. Because of this, they are located primarily by how different matter reacts and behaves. There's the first problem. How do you photograph something that's invisible? Cue more than a decade's worth of work and over 200 scientists and personnel working on the Event Horizon Telescope collaboration. By using 8 radio telescopes located across the world, the team was essentially able to create a virtual telescope the same size as the Earth itself. The telescopes involved in creating the global array included ALMA, APEX, the IRAM 30-meter telescope, the James Clerk Maxwell telescope, the Large Millimeter Telescope Alfonso Serrano, the Sub-Millimeter Array, the Sub-Millimeter Telescope, and the South Pole Telescope. The observations were a coordinated dance in which we simultaneously pointed our telescopes in a carefully planned sequence, said Daniel Marone, the Associate Professor of Astronomy at the University of Arizona. To make sure these observations were truly simultaneous, so that we could see the same wavefront of light as it landed on each telescope, we used extremely precise atomic clocks at each of the telescopes, he added. From here, over the course of 2 weeks, 5,000 trillion bytes of data were collected and processed through supercomputers so the researchers could retrieve the images and produce and render the image we see today. This task wouldn't have been possible without an algorithm that helped piece together the data developed by MIT student Katie Bauman. The data collected was so large that it couldn't be sent via internet and instead was loaded onto hard drives and shipped to Boston, USA and Bonn, Germany. The image appears as a fuzzy ring which is actually a black hole's accretion disk, a ring of dust and gas that orbits a black hole in which the abyss feeds on. What the EHTC did was pick up radiation emitted by particles in the accretion disk, particles that are billions of degrees high in temperature and that are whizzing at close to the speed of light. The reason the disk is more prominent and thicker in some areas is because the particles in the side of the disk rotating towards Earth are flung towards us faster and so appear brighter, whereas the black centre is the hole's shadow. So what does this all mean for the future? Well, by looking to the past, this image helps further cement Einstein's theory of general relativity. But what about the future of the EHTC? Researchers are hoping that the image of the M87 black hole will give us a deeper understanding of how black holes work, as well as their relationships with the host galaxies. For example, in what way has the presence of a black hole changed the development and evolution of a galaxy? Furthermore, the researchers are hoping to sharpen the image of the M87 black hole using algorithms, further enhancing the quality and giving us a finer look. In the future, the researchers, and many interested John and Jane Does, are hoping that the project will be able to capture an image of the black hole at the centre of our own galaxy, the Milky Way. The black hole, known as Sagittarius A star, poses its own set of challenges as it's more variable over shorter timescales, making it more difficult to photograph. Finally, the team has data from 2018 to analyse as well, data which incorporated another telescope, which would really increase coverage, and they also have plans to incorporate others in the future. Whatever the future holds for the project, or for the research into black holes, it's safe to say that this major breakthrough is just the start of further things to come. Hey guys, Brothers Jackson here. I decided to do something a little bit different because I'm really interested in this sort of stuff. I hope you guys enjoyed it. I know it wasn't a scary story, but there will be a scary story coming Saturday. So I hope you guys enjoyed it. Don't forget to like, comment and subscribe for more, guys. Peace out.